Welcome back to CodinGame Summer Challenge 2024. Olimbits is the name of the game. So, day 2, I guess. Last time I spent a couple of hours putting together a kind of a hacky solution to get out of wood, and now I think we can scrap most of that code because it wasn't really... okay, A, it wasn't well written, and B, doesn't quite apply to the actual game now that we have the full rule set. So, I would say we just start from scratch. Well, no, start from scratch using the framework we've already built. So, we've got 4 games instead of 1 running in parallel. Where's the music? There we go. I guess we'll start with the first one because we already know how that works. And just thinking how we want to... Alright, get rid of all this code. We're actually in the middle of the league right now. Oh, silver's open. Okay, so a lot of people are already promoted. I think we're gonna have to scrap all this. Get rid of that. Why is this erroring? Game.decide. Game.decide should just print up. So who's calling this? Nobody should ever be calling this. Why is it erroring? Oh, okay, fine. All right, so do we even want this anymore? I don't know. We'll just leave it for now. So I think the first thing to do is just kind of formalize this idea of a game state, right? Now, the game has various properties, but one of those properties is the like the map itself. For example, the string containing the hurdles. And the thing about that particular property is it's static. It doesn't change between terms. So it'd be more efficient to like kind of store it as a global variable, but then it does actually change when we move to the next game. But if we store it as a global variable, then we can actually kind of not use much space for our states, which means we can hash it and do stuff with it, like put it into trees and things like that, which we could do before, but we don't really want to be storing this map all the time with every single state. So a state would basically be where we are, where the opponents are, and how much stun we have and how much stun the opponents have. That's it, isn't it? That's literally everything for that game. So it's a small state. They're all going to be small because it's that many different registers. So but the thing is, okay, fine. Let's just have a look at all these states. So these are our positions and our stuns, okay. Archery. Is basically the XY coordinates. And the map is the wind strengths, basically, so that's static. And this roller speed skating thing. What is the goal? When does this end? Oh, Cyclical track 10 spaces long. But when does it end? Oh, turns left. So you got a fixed number of turns. The fact that it's cyclical is irrelevant here, isn't it? I mean... Oh, this is different because the GPU is isolated to this turn, and we don't know it ahead of time. So unlike these games where we can map out ahead of time the entire tree and there's nothing unknown, we know ahead of time the turns, the win strength. This one, we only know on a turn the risk order. That's interesting. Okay, fine. And this one, diving. We know the whole run ahead of time. Okay, fine. So... So, how do I get started? So we want a state to be basically these 6 numbers, and we move from one state to a new state. Going up, left, down, or right will take us from one state to another state. So basically we want to map out all the states we would reach from going up, down, left to right. Maybe attribute some sort of score to each of them. And that'll basically be it. If we can do that for each game, then we're one step there, one step closer to some sort of good program. Okay, let me just grab my coffee. Alright. So, let's start recording all the states, get all the information into the game. So, we don't need that. Let's get rid of this as well. Okay. So, racetrack, which is a string. We've got the all right. My position. I do want to separate my position from the enemy positions because I don't want to have to deal with player turn nonsense in the game. So we've got my position and we've got enemy positions. Pause. Pauses. That looks weird. Just say it's a tuple. Okay, so that's for the racetrack. We could simplify this. Let's create a new... Oh, so let me zoom in as well, because this is really zoomed out. Okay, so let's create a new class called, like... race... Hurdle. Let's call it Hurdle. Hurdle track. Alright, so... Hurdle state. So here we have... This is just one state, which varies turn to turn. So my pause, which is an int. Okay, so basically just take these things out. Enemy pause. My stun. Enemy stun. Yeah, just do it like that. So we've got hurdle track, hurdle state, which is of type hurdle state. This will simplify it. That means we don't have to have a whole bunch of things in game. So we can do one of these for each game. So alright, don't worry about the other games for now. Let's just focus on this one game. You can just try to win this one game. And that's really bad because you get 0 points if you don't focus on the other games too. But whatever, let's just try and get gold medals in this game so that we know roughly what we're doing. So we've got hurdle track, we've got hurdle state. So we want to provide these things. So change this. So we've got this. We're not looking at the enemy scores yet. Alright, so... So pos array equals these three. My pos will be pos array dot. We want to pop out whichever is our pos. So whatever's left will be the enemy poses. Yeah. Similarly, stun array equals this. My stun equals so then when we have that, we've got so that should be capitalized. We've got hurdle state equals hurdle state. So we've got my pos. So the enemy poses will be just like tuple of pos array. Then we've got my stun. And then we got tuple of stun array. This is only if I equals 1, if I equals 0 even. Okay. So after we've done that, we've got a hurdle state. So game equals game hurdle track. Oh, so we need hurdle track, which is the GPU. Yeah, they'll be populated. Okay. So game.decide. And then here we can just, I don't know, log self dot Little track. Let's just make sure we're getting stuff here. The state is not going to be readable, is it? It's going to be like... Stop. Oh, it is because we're using data classes, and that's just one of the wonderful features of data class. It just makes everything okay. So now that we know this stuff, we can start rising some methods. For example, we can now create the neighbor states. Oh, there's one other thing. State could be none. So if GPU is game over, okay, if GPU equals game over, then we'll just have to do hurdle track equals just an empty string, hurdle state equals none, else do all this. Because otherwise it will error out, so... Okay, so it doesn't error out, so we do go through multiple games, right? Yeah, we do. Good. So now everything is wrapped up here. We can now get hurdle state. So we can make a method saying so what happens when you run through a hurdle? Do you still reach? No, you stop on the hurdle. So up will jump over the next space, and everything else will just move forward by a number of spaces. Okay, fine. Get next states. So this is going to be a static class. How do you do that? No, it's not a static class. Okay, so So should we return it as a dictionary, which maps like up, down, left, right to the states you get to? So if we are stunned, then so if my stun, well, okay, first of all, what are we doing about the enemies? This is a bit misleading if we can't control the enemy's movement. Maybe my state should just be my state, because I'm unaffected by what enemies do. That might make more sense. By all means, we could use the enemy's states, but they should be separate states, shouldn't they? That makes more sense. In that case, hurdle state should just be a pause. Don't worry about the enemy. And a stun. That's it. Alright, don't worry about the enemy states for now. So, hurdle track, and then we should just do my state, and that's just our state. Okay, let's rearrange this. So, GPU is the same my. So for now, let's just store our state. My pause. My stun. So this is going to be my state, my hurdle state, and we can store enemy states separately. My hurdle state, and then in the game, my hurdle, because it matters what kind of state we're talking about. My hurdle state. And enemy hurdle states can be a tuple of other states. Doesn't matter. Let's not worry about that for now. So now, this makes more sense, because you can't affect the enemy's movements, so you don't know what the next state will be if you can't control them. But here we know what the next state will be, because the state is what we are controlling. So get next state. So if stun, if we're stunned, then we know what the next state will be. So it'll be the same pause, and it'll be the stun -1. So just return. We're just gonna map the string. Yeah, let's just do this. So we go up. can we just say key or move next state for move in up, left, down, right. Okay, so because the state is unaffected by what we actually do. So otherwise, we can move. So the easy case is the jump. If we're not stunned, hang on. Okay, just start putting together some states. So jump state equals, so if we, what happens if we go past the end of the track? Doesn't matter, because state, we can go past the end of the track, no big deal. So but we don't know, we don't know what the map looks like. This state is oblivious to what the map looks like. Is this how we want to do it? Don't we want... Maybe we should just make the track global variable. It's no point putting it in game every time. So how we're going to do this, just say, I don't know, hurdle track equals, so that's a global thing. So I feel like they should be capital letters as well. Well, this is changeable. Okay, so hurdle track. So we can use that. Alright, before we do anything else, let's make sure we're using that, populating it correctly. So we're not actually storing it in the game because there's no point. Just get rid of that logging statement as well. So, oops. Hurdle track is, so if it's game over, we set hurdle track to be none or something. Otherwise, we do this. Okay. And so... okay. Alright, now, we can say, so if we jump, we'll end up if stun on landing equals, so basically we're saying pause plus 2, so a jump move 2 spaces, but that has to be less than length of hurdle track, and hang on, and hurdle track self.pos plus 2 that's fine. I mean, we're not going to it's not going to be none when we run it. Is a hash. So if that's true, then we'll be stunned. Okay, so jump state equals, we move 2 spaces forward, and if we get stunned, then the next 3 turns, but Ku said something about it actually being 2, not 3, or depending on... we can check that now. Okay, so we should be stunned now. Hang on. My stun equals 1, so go back 1 turn. My stun equals 2. My stun equals 0. Yeah, so you basically skip one, or one is acted this turn. So the next 3 turns seems to be including this current turn. It's a bit confusing. But ultimately, the stun next turn will be 2. So it'll be 2 if stun on landing, else 0. That is where we end up if we jump. Okay, and if we run, for I in range, so we 1 to 4. So 1, 2, and 3 are the 3 distances we run. Just put them in this list. Or just say for dist in range run. So we're gonna run forward, and if we hit for, I don't know, for K in range, so it's like for so it's going to be starting from and finishing on if it's a hurdle. So we have to do this check again. Should we make this a quick method? Say define is hurdle some position K key. So return P is less than and that. So here we can say if is hurdle so plus 2 plus 0. Okay. If is hurdle for that pause, then we stop there. So state equals, so it's going to be finish that in that spot there, pause. And we're stunned. So we have a stun state of 2. And we break out of this for loop. Alright, so if we get to here, and we did not hit any hurdles, then that means we're able to run the full range. So it's basically this. Run states.append, distance dist. So it's going to be self.pause plus dist, and we do not stun. So what we end up with is exactly 2, 3. So 3 states here, corresponding to left, down, and right. We can just say return. So it's going to be up maps to the jump state, left maps to the first one, down maps to the second one, right maps to final one. Okay, it's a bit of a mouthful, but either way, we're getting mapping from a direction to state. Now, should we score these states? Just, okay, what's the most basic measure of scoring we could give? Like basically the most optimistic number of turns to get to the end. So if you're stunned, you have to wait to be unstunned, and then sprint to the end. So it's like, how do we do that? We'll just pretend there's no hurdles. So it'll be number of free space sprints if there were no hurdles. So define get. So for a given state, we want to work out get optimistic num turns till we get to the goal. So basically we're saying we've got our position. So dist to goal equals, so it's length of hurdle track And then minus where I'm standing. So that's how many spaces till the end. And then you want to divide by... So the most we can move in one go is 3 spaces, right? So divide by... Well... So... It's going to be... let's take the ceiling of this to goal divided by 3. So we round up because you need one more turn, even if you're close to the end. And we have to do int of that. Did we import? Okay, that's a simple measure for now, ignoring the hurdles. Let's make sure this runs. So okay, so decide. All right, let's try and use this. So if hurdle, hang on. Do we want to create a null state? Just so that you can still score the game over screen, so that we get a score either way, or I don't think we should. No, it wouldn't make sense because we don't have a pause or a stun. So we've got to check explicitly. If hurdle track is none, then what do we want? We want to make a scoring function ultimately. Up gives us so-and-so, down gives us so-and-so, and we're trying to minimize that score because the score is basically optimistic number of turns till we win or whatever, till we get to the end. So scores equals, it's just going to be like this. Should we just create a... Just create a tuple here. So scores will be direction, which is 0 for direction in directions. Else, so neighbor states equals self dot my hurdle state dot get next states. So that's going to be a map from up, down, left, right to some state. So what we really want is scores equals, so we want direction. No, hang on. Yeah. Scores equals. So it's going to be direction to mapped to state dot get what is it called? Get optimistic num turns. For direction state in neighbor states. So either way we get a score, and then what, just pick the so choose the direction which minimizes the score. So best direction equals minimum of scores dot keys key equals lambda scores k. I don't know. We're not really using these methods up here, are we? Maybe we don't need them. Print best direction return, or return best direction, because we're not doing multiple moves per turn. We're just returning one string. So we kind of want to take that one string and print it. Okay, will this whole thing actually work? So ideally we'd be doing a good race on the hurdle side. We're jumping every turn, it's terrible. the problem is... should we just return it as a float? Get average turns. So it's an average. So distance to goal is that. Return. Yeah, don't ceiling it. Just do distance to goal divided by 3. So it's a floating point. So moving a little bit closer is better than not moving at all. Because I think because of the rounding, they don't seem to care whether it's faster to jump or to... Oh, I forgot to add in the... Oh, the most important thing was to add in the... Alright, go back. To add in the stun. Return self.stun plus that. I mean, that might not change it though, but that's important because if right now there's nothing stopping us from stunning. So that's no good. Why are we jumping every time? Alright, so... let's see what our scores look like. Zeros. Yeah, that's no good, is it? Neighbor states equals if hurdle track is none. Hurdle track is none. Did we? We did populate it, didn't we? Oh, fuck. No, we didn't. Get optimistic num turns. I changed the name. Get optimistic average. It should remain num turns because I'm still... Okay. Is hurdle. No, what's going on? String index out of range. P is less than length hurdle track. Oh, where did this come from? It was a copy artifact. Okay, we're absolutely winning the first race, which is nice and all, but literally doesn't matter. But it's funny. So he's doing the jump. Actually, he shouldn't be jumping there. I think it's this rounding. All right, we'll go using floats instead. Because the rounding is just making it unclear where the two moves are equal or not. Well, they shouldn't be, even if they're just one space apart. All right, so now he's running, see? And that's even better. After landing, he doesn't jump again, he runs. He jumps there, but that's fine because it's equivalent to running 2 spaces. Thing is, we don't really want this to be a float. We want to... Doesn't matter. It's just a rough score for now. So the point is, we win every game off hurdle. Cool. Now the idea is if I can do this for each game, but instead of well, the scoring has to be overhauled because this is not really what we care about. What we care about is how we're doing relative to the opponents. So like it needs to be kind of a function of how far ahead or how far behind you are. But the thing is, the further you are ahead of everyone, the less it matters what move you pick. It matters a tiny bit, but it matters less. So we need a function which is some sort of like a decay function of some sort that says maybe like a probability function, which is kind of assessing the probability of winning. So if you're way ahead of them, your probability is going to be like 99%, all right? And making a slip up might drop your probability to 98% instead of 99%. So the difference is 1%. So it's like, okay, doesn't matter. The change in probability is like 1%. But if you're neck and neck with someone, then just go, and you're quite close to the goal, then just moving one space over ahead of them will increase your probability of winning by a wide margin. So then you can say, okay, this results in a 20% increase. Therefore, this move matters more in this game. So we can take the drop of 1% in this game in order to improve our probability by 20% in this game. Like something like that. Is probability really the right way to think about it? Yeah, I mean, we're not... It's not really strictly the probability, but it's sort of like the measure. I mean, we could actually make it the probability if we do some sort of like trials, like some sort of like Monte Carlo simulation of what could happen if the enemy does a whole bunch of moves, but it doesn't seem necessary. How do we compute that probability in the first place, though? Or maybe that is one way of doing it, to literally run trials where the enemy does random stuff, uniformly random stuff, and see what percentage of the time we still win. But at the end of the day, it just comes down to how close you are to the goal, doesn't it? So I'm going to have to think about this offline, do some maths on paper or whatever. But, I mean, if I could just repeat this framework for each game. So look, the archery is the simplest because it's just... You got the wind and you've got trying to get close to the center. Yeah, we don't actually ever want to use this measure here. It's just not, yeah. But the good thing about this probability thing that I've just mentioned is that it's completely uniform between the four games. If you can phrase everything as a probability of gold, then you're trying to balance that probability across all four games, and you don't need to renormalize depending on what kind of, like, this average turns doesn't normalize well between the games because they're different games. But yeah, the other way works as well. So if you basically have no hope of winning, I mean, it can be strictly zero. There are cases where they're so far ahead of you that no matter what they do, they will eventually get there because you can't stay stunned indefinitely. You always have to move at least one space before you're stunned again. So, well, anyway, I mean, your probability can be really low. It could be certain. It could be zero, and it could be anything in between. But if it's really low, and you could just write that off as a loss and not worry about that anymore. Yeah, I'm okay. I like the idea of this probability thing, but I need to get the maths right for it to actually make sense. I'm not sure whether we're actually making it a probability function or we're just mimicking the notion of probability measure. With some sort of hysteresis function of distance. Don't know. Can't think right now because it's dinner time and I don't normally do programming at this time of day anyway, but I meant to stream it earlier in the afternoon and I didn't have time. I guess I'll just finish there then for this stream. So that's like one game sort of sussed out. Like, I reckon we could get pretty far without changing any of this now. Everything we do from now on will just come down to how you evaluate. Because this is bona fide, right? This is saying these are my states that I will be if I do this, this, and this. That's non-negotiable. Like, we will be in those states if we do these actions. So we don't need to change this unless it's bugged or something. So it's really just a case of heuristically evaluating our state and yeah, it's a cool idea for a game. And like, you have to be good at all four games. Like, you cannot afford to be bad in one game because you get a flat score of 0. That's what's interesting about this. Like, it's not linear sum of your scores in each games, but it's a multi-product. Which means like you don't really want to spend a massive amount of time optimizing one game because it only gets you so much if your other game scores don't change much. So yeah, it's interesting. Is anyone else streaming this? No. All right. So that's a start, but I don't think we are anywhere near submitting. Look, this rank is from the code from Wood League. So, but we can't submit until we're getting non-zero scores. So I've got to do all 4 games, but I could probably manage all the other 3 in the next stream because it's sort of copying this framework here, just different kinds of states. Like get next state is basically the same sort of thing, but it's just checking against whatever the global variable is. Like you could almost make this I'm not going to, but you could do inheritance, or some sort of state parent class. So every state class has two functions. Get next. Wait, why wouldn't I do that? I think it might be good practice. Seems like we might as well, because it is literally each of them must have these two turns, these two methods. Get next states and, well, not that, but get score, get probability, whatever. We can have extra methods which work out intermediate scores and stuff, which will be used to compute our probability of winning. Oh no, but the probability of winning is not assessed here, because we don't know what our enemies are. Yeah, so this method is not even, shouldn't even be here. This is just a helper. This logic will be done in the actual game logic. So yeah, this is a very basic. Actually, that makes it even less necessary to use inheritance or whatever. Okay, whatever. I was gonna see if I could raid. Well, nah, no one's streaming CodinGame, so. Why does the music keep stopping? I don't notice it stops, and then it stopped for like an hour, and I've just been looking at code in silence. So apologies for that, because I normally have my volume really quiet for myself, because otherwise it will come through on the mic. So this is really for the viewers. Thunderstorm? Or fireworks? Fuck, looks like there's a really heavy thunderstorm. I guess I'm not going to the supermarket then. I've got enough food. All right. That's it for today. We've still got quite a bit of time, so we'll take a quick check of where everyone is out of people that I vaguely know. DBTR generally does pretty well. Observer Hub, welcome. You might find this interesting. This is a competition they do like twice every year, which I've been doing for many years now, called CodinGame, and it's basically a kind of like bot AI programming competition. Those are fireworks, not thunderstorms. I hope it's fireworks. Sorry. I don't know if that's even coming through on the mic. So the idea is basically you have a game and you write code for your bot and then you run it, but your code then gets run against. It's not. I think the noise filter might be filtering out. So your code actually gets run kind of like a PvP kind of style against all these people in the leaderboard, and you get assigned an ELO, kind of like an ELO weighting rank on the leaderboard. So if you improve the code and rerun it, you might get a better rank and so on. But what I love about this site is this is an amazing UI. Like, look, you've got this, the games are actually running. I can drag this left and right. I can debug. Okay, there's fewer debugging options than they had in previous games, it seems, but they used to have, you could add more labels and stuff. I guess it wasn't necessary for this game. You can go through step by step and see your logging down here, so you can see what's going on. Like this is all resizable. You got all these languages. Like this is, it's surprising that this is being offered for free, because this is a really high budget site, and you know they're running a lot of servers to actually run all these games, all these people. So this is all my past games over the last few days and who won. I can see the game in a little mini screen here. Like if I want to see what happened in that game, I can click send game parameters to IDE. And now it's actually simulating that exact seed, so I can see what happened and debug it if my AI did something weird or something. Yeah, this is a fantastic site, and it's more known in Europe than it is in America. So I imagine they're really trying to get more known in America because that's a big market. But it seems it's based in France, I think, or at least the devs are based in France. So yeah, check it out. I mean, this site also has kind of like standard like leak codey type problems, but they're more AI oriented as well. So you can do those puzzles. Oh, and there's another thing that they've introduced, which is escape rooms. They added this a couple of years ago, but they've now got escape rooms, coding escape rooms. And it's like literally an escape room game where you're in a room or whatever, you got to click on things and you got to write code to solve the puzzles. I haven't even done this, but I should do a stream where I go through these escape room games because it's like a whole different thing. That I don't think anyone's even done this before, so as a site. So this is like the training one, but yeah, so look, you can click on, you see clues, and then so like some of them you ought to use coding, some of them you don't need to, but it's teaching you how you would. So in this case, I would return 1, 2, 3, 4, but you can also type it in manually as well. And you can have a whole team of people, each with their CodinGame account, all on the same game together. So some people can be coders, some people can be puzzle solvers. So the coders can focus on the stuff that needs coding, and there's also puzzles in there which don't need coding, so it actually works as a co-op escape room experience as well. So if you were a non-coder, you could have just typed in 1, 2, 3, 4 into the thing directly. Well, yeah, okay. Well, that's one big advert for this site. So yeah, I will be doing it more over the next few days, but it's not the time of day where I normally code right now. So probably tomorrow I'll try and finish off this, because this particular game is like 4 games running in parallel, and whatever you press, so it's like you're playing 4 arcade mode games, but you have one set of cursor keys, up, down, left, or right, and whatever you press does an action on those 4 games simultaneously. So you've got to try and optimize those 4 games. That's what the current game is. It's quite a clever concept, but I've only coded one of the 4 games, so next stream I'm going to try and code the other 3 games and then try to figure out how to balance them, which is a thing some speedrunners do. I've seen people play like Pokemon and like Zelda or something where you control the same inputs, so that's actually a real thing. All right, well, thanks for stopping by, and maybe see you tomorrow. Bye-bye.